What's up, YouTube? Again, this Mr. T at Mr. T Do Numbers. Again, I'm back at it with my 5 ways to divide. This is way number 2. This is called partial quotients. Some kids nicknamed it magic numbers, right? Partial quotients is the real name for it. Partial means in parts, and quotient is the answer in division. So you're gonna find the answer in parts, and at the end you'll just add it all up. Right? You'll combine the parts back together. But again, I'm going back to the same problem. 2,472 divided by 12. Well, in partial quotients, the reason why they call it magic numbers is because you're not doing any division at all. You're just multiplying the divisor 12 times 1, divisor times 2, and the divisor times 5. 12 times 1 is 12, 12 times 2 is 24, and 12 times 5 is 60. Now the goal is to get as close to the dividend or the total as possible. That way you don't have to subtract that many times. So these numbers are too small. So what you're going to do is take base 10 increments of these numbers, which means now, instead of 12 times 1, I'm going to do 12 times 10. All I have to do is take the answer to 12 times 1 and put a 0 behind it. So that's 120. Then I'm going to do 12 times 20. I'm going to take the answer for 12 times 2, which is 24, and put a 0 behind it. That's 240. Then I'm going to do 12 times 50. 12 times 5 is 60, so I'm going to write 60 and I'm going to put another 0 behind it. That's 600. I need to keep going because 600 is nowhere near 2,472. The bigger I get these numbers, the less I will have to subtract. So the goal is to keep going until you get a number that's very, very close to your total. All right? So I've already did 1, 2, 5. I did 10. 20, 50. Now I'm going to do 12 times 100 and put 2 zeros behind the answer. So it's 12 with 2 zeros. That's 1,200, right? So I'm getting kind of close. Then I could say 12 times 200. Well, 12 times 2 is 24, and I'm going to put 2 zeros behind it. All right, so I'm right at the 2,472, I'm right at 2,400. If I was to do 12 times 500, 12 times 5 is 60, and when I put 2 zeros, that's 6,000. That lets me know that that's way too big. So we're going to cross out those 6,000, right? Now, again, it's magic numbers because it's no division. You're going to repeatedly subtract these multiples of 12, right? So the biggest chunk I can take out, I can do 2,400 or 2,400. So if I subtract 2,400, I have to put the groups of 12 outside. So this is 200 groups of 12, right? So I subtract, that's 2, that's 7. So all I'm left with is 72. Again, the goal was to get as close to this number as possible so I don't have to subtract a lot of times. So now that I've used a big chunk of 200, I only have 72 left. So I can't use 12 times 100 because that's 1,200. I can't use 12 times 50, that's 600. I can't use 12 times 20, that's 240. I can't use 12 times 10, that's 120. But I can use 12 times 5, which is 60. So I subtract 60 and I put the groups of 5 outside, right? 72 minus 60 is 12. So now I only have 12 left. I can't use 60 anymore. I can't even use 24. But what I can use is 12 times 1, which is 12. So I'm subtract that last group of 12, and that's one group. When I'm done subtracting, I have none remaining in my dividend. Now, this is where the name partial quotients come from, because the quotients are already outside. Now, all I have to do, since I already have the answers in parts, just add them back up together. 200 plus 5 is 205, plus 1 is 206, which is my answer, just like in standard form.